Hello viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, I'm going to talk about powering your computer, basically power for your computer. And that is very important given the fact way too many people are buying desktops now. Now, one thing you have to understand that when you are thinking about in a simple context, is like how bad it can be. Like you have dealt with power cuts all out your life where you had a fan did not stop rotating, air condition stopped working, TV shut down, like then how bad it can be. Now things go from bad to worse very quickly if power is bad. To give you a context of that, if you have a bad power incident, basically let's say you have a power spike that was way too bad, or let's say you had a low voltage environment where electronics did not went to cut off system but they were running on low voltage, they could overheat to a point where they could catch fire or damage every single equipment in your computer, not only your power supply, from your motherboard to hard drive driver chips also. So what does that mean? That simply means good luck trying to recover that data, and if it's important, good luck to you. So in those sort of scenario, power interruption can cause loss. Now that loss could depend how much money you are making per hour, and if you are working from home, which nowadays every Tom, Dick and Harry is doing, and because more companies are realizing that work from home is actually cheaper for them. It's like instead of having paying money like air condition, electrical bill, all the data that is consumed in that central location, it's like, hey, everybody is paying from their own end, from their own salary. We don't have to do extra for that. It's like many companies are doing that. So in those sort of scenarios, if you have a laptop, it's okay, it has its own interrupt. But if you are using something powerful like a desktop, power loss can be very problematic. Now important work can be lost in those sort of scenarios. That's up to you, like how important that work was. Like you cannot save everything. Like even though I worked in a company and I know like we are already saving files every 5-10 minutes, but what happens between that 5-10 minutes, and when we are dealing with multiple iterations of the files of something important, you want to save every 5 minutes, but you have to be sure that power cut does not happen in that 5 minutes, but it will happen. So fundamentally it is a very crucial requirement, and given the complexity of modern operating system, safe shutdown is a must. Like we are not even a scenario where if you had the luxury of like pulling out the battery from an Android phone, there's a very good chance you will corrupt the OS. So because of so many programs, some background stuff is happening nowadays, it's like if you don't shut down properly, you worst case scenario, you can get stuck into a reboot loop where your computer is trying to reboot but it can't even reboot itself, basically it can't start again, or blue screens of death. So it is a very severe thing. If you have bad power, it can be go from mildly annoying to destroying your whole life without an incident. So be very mindful. The power, we don't see it, but it is important, and it has to be of quality power. Now let's look at something, especially if you are living in a place where you have very high reliability of main power supply. Basically your mains is always on, but it does have fluctuation. In those sort of scenario, people utilize CVT, or constant voltage transformer. Now it has been phased out because of prominence of IC controlled stabilizers, and stabilizers are much cheaper compared to this, but this does not have switching delay. So this is very critical aspect, specifically for people who are dealing with some weird issues. Basically they have a UPS but it's going tick tick, is basically trying to compensate for something that generally indicates, unless you have an oscilloscope or a voltmeter directly connected to your mains, you will find out that voltage is fluctuating way too much. In those sort of scenario, in basically UPS is generally acting as a stabilizer. Basically it's trying to compensate the voltage, but because it's changing too quickly, it's like, okay, go to the lower setting, oh, voltage went up, go to higher setting, okay, go to middle setting, go to lower setting. It's doing it too quickly, and it's not good for your computer, because your computer is going through all that hell. It's like that bad electricity is directly going to your UPS. UPS is trying to compensate for that, but it's designed to compensate one bad interaction per minute. It's not designed to doing like that. So if your UPS is making sound that is like trying to do a disco, you need a CVT, and it does not have a switching delay. So you may be very tempted, hey, I can buy much bigger stabilizer with much more warranty and all that jazz for much less price. Do not buy that, because stabilizer literally has the same thing as a UPS. It will switch off the connection. Basically your mains connection will drop, then it will go to the right level when the coils are switched from A to B. So in those sort of scenario, that is okay for your fans, your air conditions, not okay for anything with semiconductor. If you want stable clean power, you need to utilize CVT. Now CVT was very prominent back in the days, but right now people don't use them simply because they do not have battery or backup. Basically if power goes, this goes. It's just a cleaning solution. Now be mindful, in some scenarios only this can save you. If you are dealing with a scenario where your power fluctuation is way too brutal, this is the only thing that could give your other equipments a chance of fighting and staying alive long enough. So CVT is first line of defense if you need to. Then we come to the most common defense, UPS. Now UPS are inherently, the normal common UPS that we are talking about is generally designed for small and compact and with generally inbuilt battery. Now these batteries are kind of small, they are 12 volt 7 amp hour. Now 12 volt is not important, 7 amp is. So if you do paper mathematics, you will come out to like 70 plus or 80 watt hour of capacity. Be mindful, it's never that powerful, it's never that efficient. So practically think of them as a 50 watt hour tank. So if you put a load on that, let's say if you put a 50 watt LED bulb into that, it will take you 1 hour to discharge this battery. So based on that, if your computer is consuming 100 watt and a UPS is single battery, generally it will take half an hour to discharge it. And if you are putting 250 watts, 15 minutes to discharge it. That's why UPS are like so quickly they die out. It's like the moment power goes, it's like, yeah, you're draining the tank. It's not like going slowly, it's like so be mindful. That's why for any system, proper gaming system, proper workstation system, or any system that is tangibly heavy load, people will never buy any UPS that is only one battery. Always buy something that has two. Nowadays I will recommend that, and this is one APC Back-UPS 1100. I provided the Amazon link down below. I would urge you to buy this. Again, if you are looking to buy this, simply because I have already tried Microtech one. It was good and all that, but there was a bad power spike event, which this also has a spike protection. So that power spike damaged my UPS, and it damaged in a weird way there, where they were like, okay, when power cut happened, my system shut down. It's like the UPS is working. UPS can I can boot my system on my UPS itself. There is no problem with that. It's just that power cuts were like interrupting me because it was not switching fast enough. And I went to Microtech service center in Bangalore, like primary service center, and they showed me with a light bulb, and it's like, sir, light bulb is not turning off. I'm like, light bulb, like it freaking turns off 60 times a second. We can't see that. It's like computer will tell you, yeah, I'm off. So that was really frustrating as well. And given the fact that batteries were soldered on, so it had normal battery, but the jack was, instead of a plug-in type, it was plugged in and then soldered. So that means you could not replace it easily. At that point I was like, yeah, I cannot recommend Microtech to anyone. So I'm utilizing APC, and I had good experience. I have this for 5 years. So from practical experience, I can specify this. Now, be mindful. These things are inherently designed for very quick response. So basically your power cut happens, this puppy should switch generally around 5 milliseconds. You should switch to your battery power supply, and your computer should not shut down. Now you might be like, okay, why the heck, if it's off for 5 milliseconds, why the heck my computer is not off? Generally 5 milliseconds is the threshold where your capacitors in your main power supply would generally drain. So the capacitors in your main power supply is holding up the tank. It's like it's also draining very quickly, but if the basically AC power supply is back online, it will start to charge back up. You will never notice it. And you can notice that if your computer is not on high load and you had a very small power power interruption, your computer does not shut down because the capacitors have enough charge. But if you are rendering something or like your high load, yeah, even minor power fluctuation will turn off your computer. And they are line interactive. This is one critical aspect, that they are basically UPS plus stabilizer, and that stabilizer, because every time stabilizer is disconnecting, it is utilizing the inbuilt battery system to provide the backup. That's why it is better than a stabilizer. You cannot replace this puppy with a stabilizer. So this has very quick response, everything awesome, but be mindful, these are designed for short run times. From inherent engineering, from their transformer, their PCBs, their MOSFETs, every controlling electronic aspect into them, they are designed for very small uses. Basically they are designed to dissipate large amounts of heat for a small duration time. They are not designed in such a way where it's like, even though it can say 1100 V or 600 watt total continuous load, if you put that puppy on 600 watt of continuous load for let's say 2-3 hours, you will roast this thing. It's not designed to run very long, and most of them are very square wave. Be mindful, your power supply unit does not like square wave. It does not want to run on square wave. For short duration, it can handle it. But if you are like, yeah, many people do hacks where they are like, okay, we're just gonna extend the terminal and plug giant batteries into the car. Batteries generally are a good choice simply because of their price to performance ratio. Don't do that, because this inherently is not designed to handle that kind of thermal load. And even if like this has a cooling fan, so it should be able to handle it. You do that, it's like your power supply unit on the computer is like, what are you doing? I don't like square wave. Don't feed me square wave for long duration of time. So that's why be mindful. UPS is good, but use them under their own designed descriptions. And generally do not buy anything that has less than 2 battery cells. There are some bigger ones that have 4, but they go idiotically expensive very quickly. So this is UPS, small, compact, easy to do, and it has line interaction function, so low voltage can handle. Now again, if you have one of these and making a lot of noise, add CVT before this to clean up the mains. Now we come to new introduction in the market, that is UPS come inverter. Now inverter is a very common household appliance in India because of our bad power cuts. So like every house has this. It's not optional. Like it's like how you have lights, fans, water pumps, and inverter. Like it's that common nowadays. So generally they are designed to run on external batteries. So battery can be sized accordingly. You can buy batteries that are very small, let's say 50 amp hour, to huge ones like I have for 220 amp hour. Single battery is that big. So depending on your use case, for most common public, generally it will go from 12 volts to 24 volts to 36 volt and 48 volt. Now there are some system that exceeds 50 volt. Being mindful, the moment DC starts to exceed 50 volt, it goes into dangerous territory. Basically, if you are wet or something and you touch that DC voltage, you're going up directly. So be very mindful. This is not something to play around, specifically if you're talking system that go like 96 volts or things of that nature. Those DC voltage are flat out lethal, not indirectly. You touch them, and because it does not have a sign, there is no on off that is going on. Yeah, you're gonna go poof very quickly. Now these things are inherently designed for long run. That's why you will find UPS that has 2 kilowatt of 2 kVA of rating, and your inverter that also has 2 kVA of inverter will be this big, while the UPS will be smaller than the inverter alone. It will like, I have the battery and the transformer, everything, and I'm smaller than you, simply because these things are designed to run for hours on end. Inherently in India, they are designed like this is a long running equipment. It's like having a drill motor on your drill. Like it cannot last very long. It is universal motor, but you look at a drill press, it's using induction motor. So it has to run for hours on end. So that is a very critical aspect. These things are designed for long operation. It's like keep using them, don't worry about it, just keep using them as long as you want them. Generally they will have much beefier cooling, and they will have active fans that are constantly on. And because of this is a new kind of add-on to society. It's like a UPS come inverter. You will always find there is a giant switch in the back. Now that switch will say UPS mode or inverter mode, or sometimes it will call eco mode or low voltage mode or something like that. The problem is because these are kind of bolted on technology onto a existing ecosystem, the UPS mode simply means it can switch within that time frame, 5 milliseconds. It can switch. Awesome. Then why the heck UPS has a switch? If it can switch in that quickly, why the heck there is a switch for that? Problem is, if it goes into that mode, it has low tolerance. What does that mean? That simply means if you are living in an area where voltage can drop down, let's say your AC main supply is supposed to be 220 volt and it drops down to 150 volt, this puppy will basically switch off very early on. So the moment the voltage started to drop to 180, it's like, nope, I'm running on battery. Now that's good and all because it protects your main equipment, but side effect is, if you are in a scenario where you are getting electricity like that, you could have like whole days where you are getting only 180 volt, and if this puppy is discharges your battery while the AC was on. That's fine. Basically main supply was on, but you are running on battery, so your battery won't last very long. Now again, you can put big battery, but they also have a limit and you have to charge them. So fundamentally, that's why there is a switch. If you have a good power supply, basically voltage reliability, this is awesome. But if you don't, that's why they have the second switch called eco mode, inverter mode, high, long running mode, or whatever have you. But generally, they are designed in such a way that it can work on very low voltage. So in case of Indian systems, generally they go to 90 volt, and in terms of high voltage, they can go to we are talking about around 300 volts. So yes, this means simply we can, like, literally you can buy anything in India and use it in USA. It would not even make a difference. Only the frequency might piss it off, but even that can be directly tolerated. So that is one thing you have to understand. Slow switching generally gives some high tolerance. Now if you have this and you are in a scenario where it's like, dude, many times I had power was on, but my sister UPS started screaming because it ran out of juice. Simply because if the voltage was on UPS mode, you can set it to higher mode and then utilize a stabilizer before this, or UPS after this. I'm doing the UPS after. I already had the UPS, so I put the, basically I have the main system providing the power, then UPS. Now because this is a sine wave system, I can run my equipment for hours on it without any issue. So one thing to understand this very thoroughly, these are as a what we call backup UPS. They are not line interactive. So if you have dirty power coming in, this will literally let that dirty power reach to your power supply unit. So depending on your main electrical utility, it could be not be a big deal, or it could be like, yeah, your power supply is only going to last 5 years. So be mindful of these things. That's why there is a switch, and it's not acting as a basically stabilizer. So be very mindful. Put a stabilizer before this if you have a voltage supply issue, and then switch it to UPS mode. Otherwise your computer will shut down and you will be like, why the heck my computer is shutting down even though when I'm in UPS mode? So be very mindful of that. Then we come to granddaddy of it all, double conversion UPS, or sometimes also called as online UPS. Now this puppy, the name double conversion actually makes more sense than online. Whenever you say, people think it's a smart UPS connected to internet. So double conversion simply means AC comes in, it goes to a rectifier, converted down to DC, and then that DC directly powers everything. So basically AC becomes DC, DC charges the battery, battery provides the DC, that becomes AC, and AC goes to your load. So that's the whole point of double conversion. Conversion one happened AC to DC, and DC to AC, two times it happened, and that's how it's working. Now benefit of this, the load is never connected to your main supply. What is that? What is the benefit of that? Power fluctuation does not happen, because you are creating your, basically you're running on generator, so to say. So you are creating your own AC, you can regulate the frequency, regulate the voltage without any issue. So in those sort of scenario, this allows the best protection out there. So because your AC mains is not connected to your load, even if you put an oscilloscope there and you're like, okay, shut down the main lines, I want to see how quickly it responds, it would not make a single blip. There is no off time, there is no 5 milliseconds, there is 0 millisecond, like almost it is instantaneous, because DC does have that luxury. So you don't even have to think about it. It's like, if you have these things, unless you have a defective unit, nothing bad should happen to you. So that's the whole point, best protection possible. Now only things that can destroy these things: A, poorly maintained unit, B, lightning. So that's the whole point. They are double conversion UPS. Now if you want to see battery rooms in servers, or you want to see like how ATMs are run, all of them are generally running on online UPS. Hospital equipments, basically if you have this is an investment, because this is providing so much reliability, so much clean power to every work equipment. Those work equipment can keep working for much longer. Basically dirty power will drain out your lifespan of every electrical component. So having this, it might be very expensive, but look from a company's point of view, it's like, dude, if we install this, let's say it costs us a lot of money and continuous money for maintenance and all that jazz, every other equipment that we're utilizing, which could be expensive computers, which could be Cintiqs, expensive art stuff, all those things will last longer, which will directly translate to you much more money saved. And nobody even have to worry about, hey, whether power was there or not. And some of these equipments can be ludicrously powerful, but be mindful, this puppy does exceed 100 volts or 200 volts, or some scenarios there are as high volt as 500 volts. Be very mindful, these things are not to be played around with. If you touch the battery terminal, the DC voltage is gonna go poof. So be very mindful with this. But it does come with this consequence that not only you have to have a giant space for this, it costs a lot of money. That's why it's in a bank. Your bank balance should be equivalent to a bank in order for you to afford this. Now be mindful, because of the importance of this, and too many people are buying high-end TVs. Microtech in India started to release this system on a smaller package. Basically they have like a 2 kilowatt, 1 kilowatt kind of package. That's small enough, because these things are generally built for like 3+. So those are small units. The idea is that you're gonna plug your sensitive equipment to that, like OLED, super expensive OLED TV, your home theater system, your gaming computer, things of that nature. Consequence, because they have internal batteries, that 7 amp hour batteries, they don't last long. They are not designed for, they are just like, just until you're if you're living in a place that can afford OLEDs and all that. Generally you are living in a situation, your colony or community could have a generator. In those sort of scenarios, basically the switch over time the UPS is gonna provide, or safe shutdown, or just acting as a proper filter for cleaning the house, and that cleaning your power. And that is very important for people who listen to very high quality audio equipments. Audio equipments do not like bad power. Like the more expensive equipment, the more fragile they become. So you have to have clean power in order to get good experience, or to make sure it does not go off. Oof. So this was my presentation on how to provide power to your computers. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends, that will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.